This example looks at a bag containing 5 colored marbles. And in the table below, we collected some data from performing an experiment. So our experiment was to pull one marble out of this bag, and we've collected some of the data here in the table after I've performed the experiment 100 times. We see that we've collected the number of times that we've pulled a red marble, a blue marble, a yellow marble, orange, or a purple marble. And then here we've also performed the experiment 600 times and collected the corresponding values for each marble. So to find the relative frequency probability of drawing a yellow or an orange in that 100 trials, well, all we have to do is think about how many of those outcomes that we did all together, right? We've performed the experiment 100 times. 18 times we got a yellow and 17 times we got an orange. So the total number of outcomes that were one or the other, we would have 17 plus 18 out of 100. So here we're looking at the probability that we get a yellow or an orange. And this would be 35 out of 100. Now we also want to answer as a decimal and a percent. So let's turn this into a decimal. It would be 0.35 as a decimal, or it could be written as 35%. So in the next part, find the relative frequency probability of drawing a marble that is not red for 100 trials. Now looking at the table here, we have 5 different colors, one of which is red. The remaining 4 colors are not red. So if I want to find the relative frequency probability of drawing a marble that is not red, well, one way we could do it is we could just add up all the occurrences of drawing a marble that was not red. But perhaps a simpler way to do it would be to subtract the number of occurrences of red from the total. So we could think of it like we're taking 100 trials, 33 were red, so we would subtract 33 from 100. And that would leave me with the number of outcomes that were not red, which 100 minus 33 leaves me with 67 that were not red. And again, here as a decimal would be 0.67, or as a percent, 67%. Part C, find the relative frequency probability of drawing a blue for the 100 trials. Now looking at the 100 trials here, the number of blue occurrences was 24. So let's compute that, right? The probability of picking a blue would be 24 out of 100 for that 100 trials, which again as a decimal, 0.24, as a percent, 24%. In the case when I am drawing from a blue in the 600 trials, so find the relative frequency probability of drawing a blue for 600 trials. Well, now we're going to use a different piece of data, which is that we had 121 blues that were pulled in the 600 trials. So that would be 121 out of 600. And here as a decimal would be 0.2016, or 20.16%. And what is the classical probability of choosing a blue? So now we would just consider the sample space of our experiment which, remember, really this is just looking at the 5 possible marbles that we could choose from. Every time I pick a marble out of the bag, it's going to be one of these 5 marbles. It's either the red, the blue, the yellow, the orange, or the purple. And the blue one is really one of those 5 possible outcomes. So the probability of choosing a blue would be 1 divided by 5. Or let's see, as a decimal, 0.20, and as a percent, 20%. Now what's going on, we were here looking at 3 different ways to compute the probability of picking a blue. And depending on the number of trials, we saw that in the case when we were performing the experiment 100 times, we had a probability of 24% of choosing a blue. When we performed the experiment 600 times, we had a 20.16 probability of picking a blue. But then the classical probability of picking a blue we saw was 20%. So what is accounting for this difference in all the probabilities associated with this one particular event? Well, we can think of this as an example of the law of large numbers. So as a procedure is repeated again and again, the relative frequency probability of an event tends to approach the actual probability. And by actual probability, we mean its classical or theoretical probability. So as we performed more trials here, right, going from, say, 100 trials to 600 trials, we saw that our probability went from 24% in the case when we were doing 100 trials to 20.16% in the case when we were doing 600 trials. And each of those was getting closer to the theoretic probability of getting a 20% probability when we consider the sample space here. And in fact, if we were to perform this experiment even more times, we may expect that theoretic or that relative frequency probability would get even closer to 20%. And one other thing here that we're looking at is the complement of an event A is denoted A bar, right? So we put the bar on top of the letter A to denote the complement of an event. And we would think of that, it's the event of all the cases where event A does not occur. So for instance here, if I say the probability of the complement of A, so A bar, that would be the probability that A doesn't occur. Versus if I just have probability of A, well, that's the probability that A does occur.